Hey everybody, welcome back to Journey to VR. So this week is super cool. I'm going to be using the Motion Graphics Toolkit with the Cloth Solver to generate this effect. This is a two-part demo. Today we're going to be concentrating in on doing the Cloth Solve and getting a mesh network to follow along a deforming object that's being generated by that cloth simulation. So let's jump into Maya and show you how to do that right now. All right, so here we are inside of Maya, and the first thing we're going to do is take this urban logo that was made using the SVG importer with the deformable mesh turned on, which gives us that awesome even tessellation. We've been talking about that the last couple of weeks in Journey to VR. We want to use this piece of geometry to generate a cloth object. So we'll just jump up to either our shelf and click the Create Cloth icon, or use the FX menu structure that lets you go to nCloth and create an nCloth object. So we'll create that nCloth object, and obviously if we play it back, gravity kicks in, it starts to drop down, but it's not colliding with any of the objects in our scene. So what we're going to do is we're going to go ahead and grab our wall, and we'll create a nCloth passive collider. So we'll go nCloth, create passive collider. And now that we've done that, obviously if we play this back, it's going to drop down, it's going to collide with the environment. Now, if you remember that QuickTime movie that we looked at previously, the urban logo looked like it was a helium balloon. So how do you get to that effect? It's actually very simple to do with the nCloth system. All you have to do is grab the object, jump over to the attribute editor and go to the nCloth shape, and sort of toward the bottom of this guy, there's a pressure tab. And inside the pressure tab, if you expand that out, you can switch it over to a volume tracking model, which is really, really cool. So I'm going to give it a start pressure of something like 2. So this is going to literally fill that object up with air. So as soon as I do that, you can see it kind of jumps and it puffs out, and it starts to rise up because of that lift model that's built into the solver. And that's really pretty awesome. Now I'm going to drop this down a little bit, and we'll just kind of fine tune this guy a little bit to sort of dial it in here. So there's a couple issues here. You can see that obviously there's some pretty bad self-collisions happening here. There's a lot of objects that are penetrating into the inside of each other. So what we're going to do is we're going to go back to the top of the nCloth shape node and switch its self-collision from vertex, which is the fastest to calculate, to full surface, which is obviously going to be a little slower, but it's going to give me a higher quality solve. And I'm going to drop this thickness down to something like 0.1 so that my solver doesn't get too choked up. So now that we did that, if we play it back here, you can see our objects are no longer kind of passing through each other. So our self-collisions look much, much better. So the next thing we want to do is we want to start to dial this in a little bit, and you have a lot of control. You know, we played around with the cloth system previously in Journey to VR, and it is just so much fun. So what we're going to be doing here is we're going to be using input mesh attract. So what input mesh attract does is it takes the original input geometry and it uses it sort of as a goal. So as I start to dial that input mesh attract up, you can see that those objects basically will come back and reform themselves. And then if I drop the input mesh attract down to a value of 0, they start to float away. And for the original effect that I generated, I had a little bit of input mesh attract sort of dialed on that guy. And I also added in a little bit of dampening just to kind of take some of the chaoticness out of some of those little pieces that are just kind of flipping around and spinning around. So by giving a little bit of drag here, they still get caught up in that lift model, but they're not quite as nuts as they were before. So that was basically all I did to get that cloth solver sort of looking like kind of like a helium balloon sort of floating around. So the next thing that we need to do is add onto this guy a mesh network that's going to give me strokes around the outside edge. So pretty straightforward workflow. We're going to go ahead and we're going to grab a piece of geometry that we're going to use as the instance piece of geometry. So it's going to be this cylinder. And what I'm going to do is create a new mesh network from that guy. So with that mesh network made, it's obviously using the standard distribution down the x-axis, 10 units, 10 objects down the x-axis. What we're going to do is we're going to switch the distribution type to be a mesh distribution. So I'm going to drag and drop in the urban logo onto our distributor into mesh input. And you can see that it switches it to scatter. Now, obviously, we want to find edges, right? So if we click this to edge, and we do a flood fill on that guy, this is cool. It's made a cylinder on every single edge. I like it, but it's not really what I want. I want just the outside edges of this piece of geometry to get those cylinders. And this is one of the things that's really nice is if you look here, you can actually use a selection set, a component selection set to drive what objects the instancer is going to use as its input. So that's really pretty cool. So what we need to do is we need to get just the outside edges of this logo selected. Now, the easiest way to do this is, for this example, is to just jump into my UV editor window and just do a couple quick little things to isolate just those outside edges. So if we go to Windows, Modeling Editors, UV Editor here, you can see that if we select our urban logo, Oops, I grabbed the cylinder. Grab that urban logo. I've got the outside edges, the face is sort of laid out here, and then these little faces on the inside here are basically all the extrusion. So what I'm going to do is I'm just going to right mouse click on top of this and select all of these faces, and then I'm going to go in here and control select, deselect the extruded faces. You saw in the viewport there, they just got disappeared. And now with that done, all I'm going to do is modify my selection by holding down my control and my right mouse click to edges to perimeter edge. So now, in a matter of a few seconds, I've selected just the perimeter edges, and I'm going to create a selection set from those guys. So we'll say create, set, quick select set, and we'll just call it set. That's totally cool. So now if we jump back onto our distribution node and I drag that set into that guy, you can see that it switched the method to be component selection set, and just those outside edges now have those cylinders stamped on there or instanced on there. So what we're going to do is use the enable scaling on the edges and just drop that scale multiplier down to make those guys look like they're just kind of stroking my urban logo, which is exactly what I wanted to do there. That's really cool. So you think all is well, everything looks good, and it does look good until we play this guy back. And as soon as we hit playback on that, you can see that we have some problems. So what is going on here? Well, what's going on is if we look at our mesh node and bring up the attributes for that guy, and we look at the mesh here, you can see that it's using Urban 1 shape, right? And if we look at our cloth object here and kind of scroll over here, you can see that we've got our transform node, we've got Urban 1 shape, which is the original shape node, and then we have the deformed shape node, which is actually what we're seeing in our viewport, which is the output cloth. So when we dragged and dropped that Urban 1 low mesh into the mesh network, it grabbed the wrong shape node. So we just need to make sure that we're getting the deformed shape node, that cloth output shape node. So how do you do that? It's really easy. Just right mouse click and say show shapes, jump inside of here, grab that cloth output shape and put it to the input mesh. And as soon as I do that, you can see our problem has now been fixed. So if we play this back here, everything looks super cool. The mesh network's going along for the ride of the cloth sim exactly how we want. And we've got that really nice sort of helium balloon effect happening. So that is basically it. Thank you so much for taking the time to watch this. If you're checking this out on YouTube or on Vimeo, make sure you go back to the area. On the area, I've recorded many other demos in Max and Maya and Unreal. I've done some really awesome interviews with some of our customers that are doing amazing work in VR. And we also have a large collection of written articles, again, from interviews done with our customers where they're sharing their best practices and things that they think are super cool in VR. So make sure you go check all that out. Thanks again for checking this out. Cheers, everybody.